JAMB 2026 candidate, welcome to calculations under capacitor. Okay, so according to JAMB, they said we should be, accustomed to calculating the capacitance of a capacitor. The capacitance of a capacitor. Capacitance is represented as C, capital letter C of a capacitor. All right. So if you need help, any shortcut, because now is the time for shortcuts. If you want to really pass this JAMB UTME, this is the time to master shortcuts. If you know you've not been preparing, you are a late preparation candidate, oh yeah, send me a message for WhatsApp, make I help you. So that means you don't take this exam again for 2027. But if you say you want to take the exam for 2027, because of maybe small money where you need to invest for your own education, I still did for you. Next year, I did for you. Okay, I will still teach you next year. All right, so looking at what we have in front of us here, JAMB must repeat question 1. The question reads, calculate the capacitance of a capacitor that stores 48 new coulomb of charge when connected to a 12-volt battery. Very easy question. This one, you're supposed to solve them under like 15 seconds. It's not supposed to take you reach 15 seconds. Okay, all the options represented in what? New farad. Okay, all the options represented in new farad. Hope you know the SI unit of capacitance. Is what? Is farad. Okay, farad. Not farad. All the options, we don't let us say options are represented in what? New farad. All right. So what's waiting they give us? They give us waiting. They give us waiting. They calculate the capacitance of the capacitor. First of all, we'll write capacitance. Capacitance is equal to question mark. Then they can say that stores 48. This one is for the what? The quantity of charge stored, of charge, 48 new coulomb for charge. So the charge Q is equal to 48, okay, new coulomb, okay, of charge. Then they can't give us waiting, connected to a 12-volt battery. They can't give us V, which is volt, equal to 12 volt, okay, 12-volt battery. All right, so the formula we'll go use here, the capacitance of a capacitor is C equal to what? Q over V. As easy as that, very simple formula. But if you look at this, you look at this, waiting they give us more, they solve, you discover say something need conversion for here. This new coulomb where they here, the standard unit for charge is coulomb and not new coulomb. Okay, and one new coulomb is equivalent to what? Is equivalent to what? 10 raised to power 6 coulomb. Okay, one new coulomb is equivalent to 10 raised to power 6 coulomb. All right, so 1 in coulomb is equivalent to 10 raised to power 9 coulomb. I think so. Okay, so you need to know all this conversion. Okay, so to convert this new coulomb to coulomb, now this thing you apply times 10 raised to power 6. Or what you go do? You need to you times am by 1 million. Because this 10 raised to power 6 now 1 million. Anyone will choose to do. If you don't want to make the answer in standard form, you do waiting. You what? You times am by 1 million. So this one we go do am like this. Bracket 48 times, we'll come put this one joiner, 10 raised to power 6 coulomb. So now this one be the equivalence. Okay, so we did set now. Our C, capacitance, is equal to Q over V. We substitute equal to 48, which is our what? Our charge. 48 times, say here, 10 raised to power 6 over, we get 12 volts as volt V, 12. Okay, so if we solve 48 divided by 12, will give us waiting. 48 divided by 12 will give us 4. Then we put our times 10 raised to power 6. Small mistake, get this conversion. Okay, if we want to convert from 48 new coulomb to coulomb, now coulomb big pass new coulomb. We are supposed to divide. It's supposed to be 48 divided by 10 raised to power 6. Okay, now it's supposed to be. So I tell you before, say this thing now 1 million. Okay, this is equivalent to 1 million. Okay, so for us to convert now, we're going to say 48 divided by 1 million. Okay, 48 divided by 1 million. If we do 48 divided by 1 million, if we put the answer for standard form, we will get this one raised to power minus. It will come be raised to power minus 6. So if we do 48 divided by 12, we'll come get 4 times 10 raised to power minus 6, which is equal to, this one is equal to, this one now in farad. Okay, so if we look at the options are represented in new farad. So to convert this farad to new farad, we'll still apply the same law. Okay, you are going to do what? Farad and new farad, which one big pass now farad. So this one will convert them back to waiting. We'll convert them to waiting new farad. So we'll do waiting, we'll come times. Then we're going to get something like 0.00001, 2, 3, 4, 5, 6, 4, 1, 2, 3, 4, 5, 6. Okay, we're going to use this one times waiting, times 1 million. Okay, if you do this one, you can't get 4. If you times that, this one will cancel this one, 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 this one will cancel this one. We are now left with 4 times 1 equal to 4 new farad. 4 new farad. Okay, so this is the answer. Among the options, pick the correct answer and drop it in the comment section. Let's move over to the next question, number 2. Let's look at the second question under capacitor and capacitance. You get? So, JAMB must repeat question 2. The question reads, a parallel plate capacitor has plates of area 0.2 meters square separated by a distance of 2.0 times 10 raised to the power minus 3. If the permittivity of free space is 8.85 times 10 raised to the power minus 12 F per M, that's farad per meter, calculate the capacitance. They said we should do what? Calculate the capacitance. Alright? All options represented in what? In new farad. First of all, let's write what they said we should find. Capacitance. Okay? We are trying to calculate capacitance in a parallel plate capacitor. Okay? Capacitance equal to question mark. This is what we are looking for. Right. What is the formula for the capacitance of a capacitor? C is equal to Q over V. Then what is the formula for the capacitance of a parallel plate capacitor? This is the formula. It has its own formula. C is equal to what? You have epsilon naught A. This thing like E is called epsilon over D. Alright? Where D is the distance, A is area. This one is epsilon. Epsilon naught. This epsilon naught stands for permittivity. Okay? Permittivity of what? Of free space. Okay? Now this permittivity of free space is the free space. The free space in the vacuum required for the what? The transfer of electric current. Okay? The transfer of current, the transfer of charge. That's this permittivity of free space. Alright? So we've already talked about what we are trying to solve here. This one is the capacitance of parallel plates. Okay, capacitor. Okay, so it has two different formulas. This one is normal capacitance of a capacitor. This one is the capacitance of a parallel plate capacitor. You use this formula for it. All right. So what we have to do, we have to look at what they gave us. Okay, so they gave us, the first thing they gave us here is what? The area. Area is equal to 0.2 meters square. Okay, they also gave us separated by a distance. Distance D is equal to 2.0 times 10 raised to power minus 3. They also gave us permittivity of free space, which is this one, epsilon naught equal to 8.85 times what? Times 10 raised to power minus 12. Okay, they give us anything again? No, always put the unit to F per meter. Okay, this distance, they give us this distance for waiting. They don't put any unit for the distance, so we don't need to convert anything since they don't put any units for the distance. So we are going to use the distance to solve like that. Okay, but this distance on the norm is supposed to be in meter. Okay, it's supposed to be in meter on the norm. I don't know why distance no be here, whether not from the JAMB question, I don't know. But if the distance is not in meter, ensure that the distance is in meter. So if I solve this question finish now, I don't get the answer. I go on say now to convert this distance to meter. What I get for here to meter to take solve. Alright, so I'll come believe say maybe this distance is in centimeter. But maybe we first solve first. Okay, so substituting into the formula. First of all, we'll look whether we need any conversion. So no conversion is needed. So we substitute straightforward into the formula. Alright, we have this formula here. That's what we are going to use. C is equal to what is epsilon naught. Okay, epsilon naught. This is the spelling of the epsilon I'm talking about. So this E, that's epsilon naught. Alright, and it's a constant. It's equal to this. This is the constant of epsilon. Okay, make you for know say na constant. Okay, it will always be given as this. Okay, if it's not given, if you need to use it, now this constant you will use. Okay, like when we start to calculate, do calculations under Coulomb's law. Okay, we will use something like this. They solve. Alright, so you have to know this constant too. Alright, so substituting, what do we have next? We have epsilon. What's our epsilon? 8.85 times 10 raised to power minus 12 times what? Area. What's our area? 0.2. Okay, what else do we have? We put our over. What do we have below? We have distance. What's our distance? 2.0 times 10 raised to power minus 3. Alright, so we'll come do the power. So we solve the power. If we solve the raising power, remember saying only up and down we get raising power. Okay, up and down, that will get raising power. So if I put and say brackets, we have 12 here. Put small brackets here. Minus 12. Remember, divide will come turn to, for that indices law, divide will come turn to waiting. Minus. Okay, minus. Bracket open minus 3. So if you do the minus, you will get 9. Okay, that will give us 9, Abi. It will give us 9. Okay, so we are now going to be left with minus 9. Alright, so raised to power minus 9 equal to minus 9. Therefore, our C now, when we do this, C now is equal to 8.85 times 0.2. It will give us about 1.77. Okay, over what do we have below? We have 2. Okay, 2. Remember our power we don't solve. So over 2. If we do this one divided by 2, so we are going to be left with 0.885 times our power 10 raised to power 9. A bit minus 9. Okay, so this answer is in farad. Okay, this answer is in farad. So if we bring this here, we are going to minus this one. It's going to be raised to power 8. So it's in farad like this. So if we should convert this, since this thing, those say we don't already see the answer. We don't see the closest answer. But if we should convert this to what? To new farad, we are going to do this one. So we are going to do this one times 10 raised to power 9. Something like this. We are going to do 0.885 times 10 raised to power minus 9 times 10 raised to power. Let's solve capacitor in series. Very, very easy. Okay. If you need any assistance, send me a message on WhatsApp, or you need any material, send me a message on WhatsApp. All right. So capacitors in series. How do we solve? How do we solve capacitors in series? Let's look at the question we have in front of us. JAMB must repeat question 3. The question reads: 250 new farad parallel plate capacitors are connected in series. He said 2. The combined capacitor is then connected across 100-volt battery. Calculate the charge on each plate of the capacitor. All options are in standard form and represented in what? In coulomb. All right. So what do we do next? They said we should do what? We should calculate the charge on each of the what? Plates of the capacitor. Remember, this capacitor is connected in series. Okay. And capacitor in series, the formula for capacitor in series is capacitor. Okay. Capacitor is equal to 1 over C1. Okay, let's put it for series. I'll put it, okay, wait, for series. For series connection, okay, 1 over C1 plus, depending on how many they give you, 1 over C2, and so on and so forth. If they give you up to C3, they give you, but in the question here, they said two capacitor, okay? They said 2 connected in series. And if capacitor is connected in series, to get the total capacitance, you are going to need to do what? You are going to do this style that you have to times and you divide. Okay, but if it's connected in parallel, you will have to just add, you plus, and get your answer. Okay, so just know that. So for capacitor series, you do that style where you say you need to multiply, and you what? Plus. Okay, and you add, or you minus, depending on what you have there. It's add. Okay, then you add. Okay, then for parallel, what do? You just add up everything and you get your answer. All right, it's the opposite of resistor or resistance. The one you do in resistance is opposite. You know, resistance in series, that's the one you plus. But here, capacitors connected in series, you are going to apply that LCM kind of thing. But I don't use LCM. Okay, so here, continuing with this, what we have here, remember they told us to find what? Calculate the charge on the plate of the capacitor. Okay, so the formula of charge is what? Charge, which is Q, is equal to what over V again? CV. Okay, calculating charge on a capacitor is Q equal to CV. That's capacitance times volt. But looking at the question, what were we given in this question? We were given what? The first thing we will give, they say two parallel plate capacitor. 2. They get this one. Now this one will be their capacitance. Okay, so C1 equal to 50 new farad. C2 is equal to the same 50 new farad. Okay, what else were we given? They say then across a battery with volts. Okay, this one is like potential difference, or it will be represented as volts. Okay, V is equal to 100 volts. Okay, which other thing again they give us? Okay, they ask us to find the charge, which is Q. Q now is equal to question mark. That's what we are looking for. Okay, so looking at this formula here now, this particular formula for charge, we get C. We don't get C, which is total capacitance, total internal capacitance. We don't get. We get V. Yes, we get V. So we need to find this C first so that we can apply this formula. So before we find this C, we are going to apply this formula to find C. Since it's in series, and we are going to apply it according to series capacitance. And they give us C1, they give us C2. So what are we going to do? We move straight into the application. When we substitute into the formula, we are going to be left with C is equal to 1 over, what is C1? 50. Okay, plus 1 over, what is C2? The same 50. Okay, what do? We times and we, you know the check now. You times, then you plus. Okay, 50 times 50 over 50 plus 50. 50 times 50 will give us what? 50 times 50 will give us, that's about 2,500, right? 25 over 50 plus 50, 100. So if we solve, this is going to give us equal to, you divide it, it will give you this 0 cancel this 0, this 0 cancel this 0. 25 divided by 1 will give you 25 new farad. All right, so this one is our capacitance. So we don't get capacitance now. All right, this C now. So our capacitance is equal to 25 new farad. But is there any need to convert? Yes. Capacitance, we don't use capacitance that is in new farad to solve. We have to convert it to what? Convert from new farad to coulomb. Because coulomb is bigger, we are going to have to divide, not times. we are going to have to divide because Coulomb is bigger. So it's going to be 25 over 1 million. You know 1 million is equivalent to 10 raised to power 6. Or you can do anyone. So if you do it 25 divided by this, you are going to be left with 5 times 10 raised to power minus 6 Coulomb. So this is what we are going to get. Okay. So in essence, we are going to solve immediately. So if we solve now, bringing this, we now have this. And if you look at the formula, let's bring this formula down so that we can solve where Q is equal to CV. Okay. Q now will be equal to what? What is C and V? C is what? 25 times 10 raised to power minus 6. Okay. Times what is V? 100 is the volt. 100. And that will give us what? When you times it, it's going to give you 25,000 times 10 raised to power minus 6. Okay, 25,000 times 10 raised to power minus 6. If you look at the option, do we have any option like this there? No. So we will have to convert this. Okay, we are going to convert it to two significant figures. All the options now, two significant figures they carry. Some get one significant figure, some two significant figures. So let's convert it to two significant figures to see if we are going to find our answer first. Okay, so if we put a point here now, okay, if we put a point here now, that shows we are going to minus 1, 2, 3 from this raising power. You get. So if we put points here now, we are going to get 1, 2, 3. So we are going to minus 3 from this one. So it's going to be 2.5 times 10 raised to power minus 3. Do we have any of this in the option? Yes, we have something like that among the option. Option B is the correct answer. Okay, so this is our final answer. Let's move over to the final question on capacitance or capacitor. That's capacitors in parallel. The question we have in front of us here under capacitors in parallel reads, JAMB must repeat question 4. The three capacitors of capacitances 2 new farad, 4 new farad, and 6 new farad are connected in parallel across a 12-volt battery. Calculate the equivalent capacitance. It's very easy now. All the options are represented in what? New farad. Equivalent capacitance. That's C equivalent is equal to 1 over. Sorry, no. Since it's connected in what? Parallel. Remember, parallel is the one you add. In capacitance or in capacitor, you add parallel. So it's now going to be C1 plus C2 plus C3 and so on and so forth. Depending on how many. Okay, but here now C1 to C3 they give us 1, 2, 3. Only 3 capacitors. Alright. So it's going to be equal to C equivalent is equal to C1 is what? 2 plus C2 which is 4 plus C3 which is 6. 2 plus 4, 6 plus 6, 12. That's 12 U farad. Among the options, pick the correct option and drop it in the comment section. Very easy.